Good morning, students. Today we are going to start some more questions related to permutation and combinations. Question number 8 of exercise 7.3. How many words with or without meaning? How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? Means the letter must not be repeated in the given word. The given word is equation. And you can see that how many alphabets are there in this word equation? 1, 2, 3, 4, 5, 6, 7, 8. And we have to make the word that is with or without any meaning. चाहे उसका मीनिंग हो चाहे ना हो, but we have to make a word from the letters used in this given word equation without any repetition of the letter. So it means that here the value of n is equals to 8 and we have to take all the objects at a time from the given word. So total words formed from the given word by taking all the letters without repetition is equals to NPR, that is 8P8, that is factorial 8 upon factorial 8 minus 8, factorial 8 upon factorial 0. As we know that the factorial 8, the factorial 0 value is 1, so it becomes factorial 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So its product is 40320 is our answer. So this much words, 40,320 words will be formed from the given word equations when all the letters of the given word are taken at a time and without any repetition of the letters. Okay. Now let's move to the next question. Question number 9. How many words with or without meaning can be made from the letters of the word Monday? The given word is Monday. So how many alphabets? 1, 2, 3, 4, 5, 6 alphabets are there in a word Monday. Assuming that no letter must be repeated and we have to form a words when the 4 letters are used at a time. So in the first case here n is equals to 6 and we have to take 4 letters at a time, so r equals to 4. So total words formed from a given word by taking 4 letters without any repetition that is NPR 6P4, and 6P4 directly also we can simplify as डिसेंडिंग ऑर्डर में 6 से लेके 4 न्यूमेरिक नंबर्स तक लिख दीजिए। 6 इंटू 5 इंटू 4 इंटू 3। 6 से स्टार्ट करिए, r की वैल्यू 4, सो 1 2 3 4, स्टॉप इट। 6 इंटू 5 इंटू 4 इंटू 3, सो 60 30 120 and 360 is our answer. Now the second question, second part of it, all the letters are used at a time. Now in the second part here, n is equals to 6 and r is also equals to 6. So total words formed, total words, that will be total words formed from a given word by taking 6 letters without any repetition will be NPR 6P6, that is equals to factorial 6, 6 into 5 into 4 into 3 into 2 into 1. So 6 into 5 30, 30 into 4 120, 120 into 3 360, 360 into 2 720. So in the third case it will be 720. Now comes the third. Let us see. All the letters are used, but first letter is a vowel. So you can see that in this given word, vowel, this is our vowel, O is a vowel and A is a vowel. So here in the given word, out of the 6 alphabets, 2 of the alphabets O and A are vowels. So what is asked, all the letters are used, but first letter is a vowel. Since in a given word only two vowels, that is O and A, and this O and A must come in the first place only. So the first place of a word, the first place of a word can be filled by 2 ways. As we can take O also in the first place, or A also we can take in the first place. So how many ways? Total number of ways when the word will start with a vowel only. So 2 vowels, so there will be 2 ways. When one number we have inserted, suppose I have taken the word alphabet first letter O. Now I am left out with more 5 places. 1 2 3 4 5. This place is fixed for the vowel. Either I should take O or A. Now the rest of from the 6 alphabet, 6 places, already this place is fixed for vowel. Now rest remaining unfilled places are 5 places. So we have to 5 places can be filled by using the rest of the 5 alphabets by factorial 5 ways. Rest of the 5 places can be filled by factorial 5 ways. So therefore total words will be formed equals to first work 2 ways into second work factorial 5 ways. So 2 into 5 into 4 into 3 into 2 into 1. So 5 into 4 into 2 into 1, 5 into 4 20 into 3 60, 60 into 120. So 2 into 120 equals to 240 words will be formed. Now the next question number 10. It is very important question. Question number 10. In how many of the distinct permutations of the letters in the Mississippi do 4 I's not come together? The given word is MISS, ISS, IPPI, Mississippi. MISS, ISS, IPPI. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the given word is Mississippi, and we have to form the distinct permutations when these 4 I's not come together. Whenever it is asked that the particular letter, the alphabet doesn't come together, first, without any restriction, it means that you take all the alphabets of the given word and form the number of permutations. And then you form when I comes together, total permutations without any restriction, and then you take the total number of permutations, form the total number of permutations by taking all the I's together. And after getting the total number of permutations, when you take all the I's together, that number you subtract it from the total permutations which we have formed without any restrictions. You will get when the I's do not come together answer. Let us see, we will work out with this. So here you can see that in this word some of the alphabets are repeated. So be careful in repetition case. Now here N is equals to 11 alphabets are there. I comes 4 times. 1, 2, 3, 4. S also comes 1, 2, 3, 4. 4 times, and P comes 2 times. You can see clearly in this word that there are total 11 alphabets, and out of these 11 alphabets, 3 alphabets are repeating. I repeat 4 times, S 4 times, P comes 2 times. So total permutations formed without any restriction, will be formula. Listen carefully. This you can write it as P, this you can write it as Q, this you can take it as R. Factorial P, factorial Q, factorial R. Formula. If the 2 alphabets are repeated, our formula will be up to 2. Factorial N upon factorial P, factorial Q. If 3 alphabets are repeated, then our formula will be factorial N upon factorial P, factorial Q, factorial R. If suppose 4 alphabets are repeated, then our formula will be factorial N upon factorial P, factorial Q, factorial R, factorial S. So here now I am going to substitute their values. Factorial 11 upon factorial I comes 4 times, factorial 4, S comes 4 times, factorial Q, that is 4, and P comes, that is R, 2 times. And after simplification, I will get the answer as here 34650. This is the total number of permutations which are formed without any restriction. You can simplify it. Okay, 11 into 10 into 9 into 8 into 7 into 6 into 5 into factorial 4 upon factorial 4 and 4 into 3 into 2 into 1 and factorial 2 will be again, this will be 2 into 1. So factorial 4 cancel. 4 2s are 8, 3 2s are 6, 2 5s are 10 and this 2 and 2 cancel. And when we multiply these numbers, remaining numbers, you will get 3 4 6 5 0. Now this is the total number of permutations without any restriction. Now when all these i's comes together, now when all the i's comes together, then if this I becomes completely one, this comes together and we are considering now it as one alphabet. So total number of alphabets we are starting, we are having 11. 11 में से हमने 4 निकाल लिए -4, लेकिन we have taken together all these 4 alphabets I as one. So I am now going to add 1. From the 11 alphabets, 4 i's first I have taken out, and then these 4 i's I make them together and again put it on. So plus 1. So 11 minus 4 7 plus 1 8. Now in this case, here S will only occur 4 times and P will occur here 2 times. Sorry, P, correct. S occurs 4 times, P occurs 2 times. Now, total permutations when i's come together will be equals to factorial n. This will now become n, factorial n upon factorial p, factorial q. So factorial n is factorial 8, factorial 4, factorial 2. So now in this case, number of alphabets will become 8, and in those 8 alphabets, S is repeating 4 times and P is repeating 2 times. So our formula will now become factorial n upon factorial p, factorial q. Stop. And factorial 8 upon factorial 4 into factorial 2 will become equals to 840 when we calculate it. Now this number we have to subtract it from this one to get when the i's do not come together. So now total permutations when i's do not come together, that is 34650 minus 840 will give us 33810, our answer. Okay, once again I am going to explain you this question. It is a very important question. So such type of questions from the another textbook refreshers you can practice. The given word is Mississippi, consists of 11 alphabets in which I comes 4 times, S comes 4 times, P comes 2 times. So first of all we will form the total number of permutations without any restriction. So factorial n upon 3 are repeated. So we will take factorial P, factorial Q, factorial R. After simplification we are getting 34,650. Now when all the i's are taken together, it means that from out of the 11 alphabets I have taken 4 i's out. 11 minus 4 7. और उन सभी आइज को एक करके फिर मैंने उसमें इंसर्ट कर दिया. So it becomes 7 plus 1. Now total alphabets will become 8. And in those total alphabets, 8 alphabets, S comes 4 times, P comes 2 times, S, I we have taken it together, 1. So total permutation when I comes together, factorial n, only 2 of the alphabets are now repeated, S and P, factorial P, factorial Q. So factorial 8 upon factorial 4, factorial 2 equals to 840. Now total permutations without any restriction. From this we will subtract the total permutations when i's come together. So when we subtract 34650 minus 840, we get 33,810 permutations are there when i's do not come together.